people that tip is just a simple attendance system. But have you ever wondered how this car talks to the screen? In our 4 semesters of our robotics, we realized that this isn't just a magic. It is a digital handshake. This video is for the future student in this vlog. We will share what we did, what we learned, and some real tips that can help you get through this software without losing your minds over the wire.
To start, let's talk about what are the input devices we have worked with and their functions.
First, the RFID or radio frequency identification reader usually looks like a small flat rectangular box or panel. It may have a smooth plastic surface and a small light indicator. The RFID tag looks like a PIN card, similar to an ID or ATM card, a small keychain or a speaker. This device uses radio waves to communicate wirelessly. When a tag is placed near the reader, it sends back a unique ID that the microcontroller reads and processes. Next, a 4x4 keypad looks like a small square pad with 16 buttons arranged in 4 rows and 4 columns. The buttons are usually labeled with numbers 0 to 9 and symbols like asterisk and hashtag. It looks like similar to a calculator or telephone keypad. This device works using rows and columns. When a button is pressed, the microcontroller scans this connection to identify which key was pressed. Lastly, an IR receiver is very small and usually black. It has a round or rectangular head with 3 thin metal legs at the bottom. It looks like a tiny sensor that can be placed on a circuit board. This device detects infrared signals from a remote control and converts them into digital codes that the microcontroller understands.
Overall, IR receivers are the most challenging to use because they are sensitive to light and need proper signal detection. While keyboards are simple but require more connection pins, with less than I2C multi-keys. RFID is the most user-friendly since it only requires tapping a tag without remembering password or aiming a remote. Among the three, RFID also has the widest application such as access control, inventory tracking, pet identification, and contactless payment, while keypads are commonly used for door, locks, and control panels. And IR receivers are mostly used in devices like TVs and air conditioners.
Moving on to our debugging experience, during Activity 3, IR-controlled servo door lock system, we encountered a challenge while testing our project. We noticed that the servo motor couldn't function properly even after repeatedly checking the code and ensuring that all wired connections were correct. At first, we assumed the issue was related to programming or loose connections. However, after further inspection and testing, we discovered that the servo motor itself was already defective. As a temporary solution, we tried tapping the wires to stabilize the connection, which worked occasionally. But when the servo motor completely stopped responding, we decided to replace it with a 360-degree servo motor.
Go!
This experience taught us that not all technical problems are caused by coding errors or wiring mistakes. Sometimes the issue lies in faulty hardware. It also reminded us the importance of thoroughly checking the components and being prepared to find alternative solutions when unexpected problems arise. Furthermore, our debugging experience taught us the importance of following an organized, step-by-step procedure in order to ensure success in our activities. It is as follows. First, we carefully read and understand the module before starting the activity to make sure we know the correct procedures and instructions. Second, we discuss the task as a group to clarify any confusion and plan how we would complete it. Third, we assign specific tasks to each member based on their strengths and abilities so that everyone had a clear responsibility. Finally, we worked together, communicated properly, and managed our time well, which helped us to stay organized, work efficiently, and successfully complete the activities smoothly.
Moreover, during our sessions, we were
able to combine the RFID or by-port keypad and IR receivers with LEDs, LCDs, buzzers, and servo motors to build interactive systems like attendance checkers, password-protected locks, and IR control doors.
For example, when an RFID card was scanned, the LCD greeted the user. When the correct PIN was entered on the keypad, the servo rotated to simulate unlocking a door. When a button on the IR remote was pressed, the system responded by locking or unlocking while updating the display. Seeing these components work together made the project feel more real and practical.
Additionally, the LED, LCD, and buzzer were very helpful in showing what the system was doing. The LED gave quick visual confirmation, the LCD clearly displayed instructions and results, and the buzzer provided audio alerts.
During testing, this feedback saved us a lot of time. If the LED turned on but the servo did not move, we knew the issue was probably with the motor. If nothing lit up or beeped, we checked the input or wiring. Because of these signals, we could quickly tell where the problem was, instead of guessing.
Step by step, the systems become more complex, and at the same time, our confidence and understanding grew.
As for the integration process, we started with simpler activities like connecting RFID to an LED before moving to the complete RFID door lock system. This allowed us to understand the basics first, such as how inputs are detected and how conditions are processed. Once we are confident with that, adding a servo motor or integrating a keypad or IR remote felt less intimidating.
Though, while we often learn about RFID, 4x4 keypads, and IR receivers in school for basic tasks like scanning cards or controlling LEDs with remotes, these tools can be used in simple, helpful ways in daily life too. RFID tags go to reusable coffee cups at local cafes to track loyalty points and cut down on waste. 4x4 keypads are used on home tool storage boxes so family members can type a short code to get what they need without keys. And IR receivers are built into smart plug adapters, letting you use an old TV remote to turn on lamps or chargers on and off. So, while seemingly simple, these technologies demonstrate how basic concepts can be creatively applied to enhance convenience and sustainability in our everyday routines.
Thus, to conclude our video, we want to tell you that failure is something you cannot avoid in robotics. We experienced this firsthand through coding errors, wrong wirings, and faulty components. However, although frustrating, these moments became our biggest learning opportunities since they help us realize our weaknesses, which was our limited understanding on modules and overdependence on pre-written codes and diagrams. And once we identified these shortcomings, we were able to improve them. Over time, we were able to fix problems and even make enhancements in our systems without constantly relying on references, which made us really proud and happy. Thus, from these experiences, we want to remind you that the process is just as important as the result. Knowing how something works is as important as making it work. So in every robotics session, don't just aim to finish the task. Also, try to understand why and how each component you use functions. Because what you learn here may one day help you and others in a world where robotics is deeply connected with our daily lives.